geometric definition is, because there's foci, plural of focus. There's two foci on these graphs, so it actually generates the equation of the ellipse. We're going to draw some, of course, and I'm going to talk about the eccentricity. That kind of is a value, a number, that tells you how oval, or like elongated, versus how closer to a circle it might be. So nothing too stressful. Okay, let's look at this. So ellipse, of course, oval curve that looks like an elongated circle. So like the red one here. So you will have these two foci points. Again. So our geometric definition of an ellipse is the set of all points in the plane, the sum of whose distances from two fixed points is a constant. So if you added, of course mine's in color here, if you added like the blue lines together, it's going to be the same if you added the black ones. If you pick any point on here and I go to from the focus to that point and you add them, you get the same value. That is technically the geometric definition of an ellipse. Is that how we're going to generate and draw the pictures? No. And of course you can do these on your graphing calculator again in that apps menu under conics, but it's kind of like the parabola, really isn't all that helpful if you ask me. Now the equations, this all looks crazy to me. Don't think, oh my gosh, I have to memorize all of this. You don't. You're going to see this is super easy to draw. Now, one thing that changes are these denominators, the location of where a squared is. Now, a squared is always going to be the biggest denominator. So I'm not like, oh my gosh, what's a squared, what's b squared? The biggest denominator. So if the biggest number is under x squared, it's going to be horizontal, it'll be longer. If the biggest number, the biggest denominator is y squared, it'll be vertical. So that's just affecting, is it horizontal versus vertical? And you'll see it's going to be super easy to mark up. Vertices, of course, are those endpoint coordinates of it, how long it is, which you could just literally count it, which you'll see here in a minute. And the other equation we're going to need is this foci. And notice it's the same regardless if it's horizontal or vertical. Elliot.
Isn't the equation just the equation of ovals that you gave us before?
When I snuck one in a while back, yes, it's very similar.
What would the difference be?
I'm not sure which equation you're particularly referencing.
I think it was on the radial, not radial, but on the polar graphs when we were. I think
If you find it, show it to me. I just want to make sure I'm thinking of the same exact thing you're thinking of. Okay, so super easy. Yeah, we got a lot of stuff to answer. I'm not going to get crazy with it. Now, all of these, just like your parabolas, are centered at the origin. Eventually, we will get off the origin, okay? But everything's centered at the origin. So I'm starting there. I'm going to draw it first, and I'm going to answer this stuff. Now, I'm not even like, oh my gosh, which is the bigger denominator? Is it horizontal, vertical? Okay, it doesn't matter. You'll see it. So first, I see the 9. 9 is under x squared. I'm going to square root 9. Square root of 9 is 3. It's under x. So that's how far left and right you are counting from the center. So right 3, left 3. Got it. Okay, then I'm going to look at 4. It's under y. I'm going to square root 4. What's the square root of 4? 2. So up 2, down 2 because it's under y. And I'm going to try to draw an oval. I mean, it could be better, could be worse. Let's just say that. Now, clearly your larger denominator is the 9. So it is horizontal. So the vertices then are on the left and right endpoints. These are what we're looking at for the vertices. You don't have to label them B. I'm just going to put it on for the first one. So I'm going to write the order of pairs. Negative 3, 0, 3, 0. Can you put plus or minus 3, 0? Yes. And sometimes I do just put plus or minus 3, comma 0 and make my life easy. Okay, length of the major axis. So again, the vertices are on the major axis. So this is your major axis. I need the length of it. How many total units is that? 6. And then your other axis, the alternate one, is the minor. So how many units is the minor axis? What's the length of that guy? 4. We went up 2, down 2. So you can get it all right off the picture. Now, foci, okay, now I gotta do a little work. We gotta put the focal points on here. So to find our foci, it's that c squared equation. Just gonna click it back a second here. So I'm using this a squared minus b squared. Now a lot of times, it's easy to be like, oh, what's a squared, what's b squared? You're subtracting. I need it to be a positive. So am I going to do 4 minus 9 or 9 minus 4? 9 minus 4. I need it to be positive. It is always the bigger minus the smaller. Okay, 9 minus 4 is 5. And then I root it. Now, I'm going to graph square root of 5, okay? Because I'm going to mark the foci on here. So you are going to have to punch that in your calculator. I did it earlier. It's about 2.2. So the foci are on the major axis. So my major one, I highlight it here in red. So from the center, I'm going to ballpark it, right? 2.2, I don't know, maybe that's 2.2, and left 2.2. So those black dots are your foci. And when I write the ordered pairs, though, I want them as exact answers. So I'm not going to use the 2.2 version. I'm going to use the square root of 5 version. So I went right square root of 5, bless you, and left square root of 5. And again, you can combo that and just put plus or minus square root of 5. I don't care, that's totally fine. That's as wild as it gets to draw these, okay? You might have a little decimal work on the foci sometimes, but nothing too crazy. Okay, so little different. So you're not quite in standard form. We're super close to standard form. Just back to our formulas here. Easy way to tell I'm not in standard form, it has to be set equal to 1 for an ellipse. Also for a hyperbola too when we get to that. So I need them set equal to 1. So I'm going to make that happen pretty easily. I'm just going to divide by 144. Okay. So of course, we need it, probably our calculators. 16 over 144 does reduce down. It goes into there 9 times. And 9 goes into 144 16 times. So there's my standard form. Now, easy enough to draw it. Center, of course, 0, 0. 9's under x. I'm going to square root 9. 3 under x. Left 3, right 3. 16 is under y. I'm going to square root that. 4 under y. So that's your up and down, up 4, down 4. And let's try to draw it. Hey, that's pretty good. I'm kind of proud of that one. kind of proud of it. Okay. Now this time, of course, it doesn't ask us a truckload of questions, but if it did, this time clearly it's taller than it is wide. It's vertical. So your major axis is always the longest one. So this would be the major, then the horizontal would be the minor, if it asked, but it didn't. I just can't help myself. Okay, but it does want us to do the foci. All right, I'll do the foci. Let's get that done. So I'm using my c squared formula. Always the bigger denominator minus the smaller, because you need it to be positive. 16 minus 9, you can see I got to let her know it's 7, but I was like, well, what's square root of 7? So that's about 2.6. I punched it in earlier. So remember, those go on the major axis, which ours is vertical this time. So up 2.6, then up, down 2.6. So if I had to write out, if there was a blank and I had to write out what the foci are, ordered pair, this is as wild as ellipses get. I'm going to do eccentricity in a minute, but it's super easy, I promise. So any questions on those first two? Okay, let's write some equations and carry on. So the vertices of an ellipse, let's graph it here too. I'm such a visual learner. I like to kind of look at the picture and graph it as I go. So vertices 4, 0, negative 4, 0. Okay, so vertices are on the x-axis, so I know it's horizontal. I know that first denominator better be big, or I have screwed this somehow up, okay? So it says the vertices of that, find its equation. Okay, I'll take the equation. So I know x squared y squared. Now I can of course get you what this first denominator is. What do you got? From 0, 0, how far did you go each way? We went 4 each way, 4 squared, 16. So the problem is, you need b squared. Okay, because I don't know, notice I haven't drawn it yet because I don't know how tall it is. I'm going to try to figure that in a minute. But I'm also going to mark the foci on here. I'm going to do them in green. And I'm just going to label F, so we've got so many points here, don't get too carried away. Now, that tells you then what C is, because of course that's the distance from your 0, 0, your center, to the foci. So I know C is 2, because we're going 2 right, 2 left. So I'm going to use my C squared equation now. C squared, 2 squared. We know our A squared, because they told us these were the vertices. That's your major axis, so A squared is the 16. And then I can just keep going and solving for B squared. Let's take 16 off. Don't let it scare you that it's negative. We have negative on each side. So I'm just going to come up here and throw a 12 in there and circle it. Now I still need to finish the sketch, so, okay, because it wants you to draw it. So now that you do know the 12, I can figure out how far up and down to go, but I'm going to need my calculator for it, because unfortunately square root of 12 is not a nice whole number. We're going to have to approximate it. Square root of 12, so you're going to look 3.5. So I'm going to go up 3.5, down 3.5 from the center. Got it. Now I'm going to draw it. There we go. So a little trickier sometimes, or I shouldn't say trickier, but a little bit more work, I should say, involved to figure out your B squared. Any questions on that? All right, last thing we got, we're on eccentricity. So eccentricity is just a number that will kind of tell you how elongated, how oval it is, versus more of a circle, okay? So if you look at your equation here to find the eccentricity, and you'll have all the values, there's no extra calculations, you just have to know you're doing C over A. So I'm going to divide C over A. Now, if you get something closer to 0, it's going to be more closer to a circle. If you get a value closer to 1, it's going to be more oval or more elongated out. So that's why we like to know the eccentricity. Closer to 0, closer to a circle, closer to 1, more stretched out, more oval. So find the equation of the ellipse, blah, 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 sketch its graph. Okay, so you know I like to mark on the graph and draw it as we go. So first thing I'm going to mark are the foci. So 8, 0, negative 8, 0. And I just label F. You don't have to see the foci. Got it. Now, so I'm thinking about what is it right now that we know. So we know we can use our C squared equation because we have the foci. We also have that E is 4 over 5. Now, whenever I have to write equations of these figures, because we're going to do hyperbolas and some other graphs, I always kind of set it up a little bit. I know we're going to have these fractions added, and I know it's going to equal 1. So unfortunately, I don't have any like major or minor axes or the vertices yet to get those denominators, so we're going to have to kind of figure it out. But I'm going to use this little tidbit of information to help us. Now, C is 4 over, or E is C over A, 4 over 5. But I'm like, wait a minute. Our distance, let's put the center on here, I guess. Our distance to the foci is 8 units. So I'm like, shouldn't C be 8? And I'm like, oh, we're good at fractions. I can figure this out. What's A gotta be? 8 over 10, isn't that the same as 4/5? Aren't there other equivalent forms of 4/5 out there? Sure are. So I know this is going to have to be 10. Because 8 over 10 is the same as 4 over 5 reduced. Now why is the 10 significant? That's one of your denominators. In the squared form, of course. 10 squared is 100. So the first question for you, which denominator is 100, the first or second? First, I heard it first. Because you're on the x-axis. Your foci are on the x-axis. So that's going to be your major axis. So the bigger number better be under x. So now, of course, we have to figure out what b squared is. That's my next little project I'm going to work on. Now, I'm going to use my C squared equation. I'm just writing it down so it's in front of us. We just figured out a squared was 100. I need b squared. And I'm going to be smart here. For c, are you using the 4 or the 8? For our picture. 8. We're using the 8 because they gave you the reduced version of the fraction. Our foci are 8 units from the center. We're using the 8. I don't know why I put 8 squared. I should just put 64 there. You can handle it. Okay, solve for b squared. I'm going to subtract 100. 64 minus 100. So it's negative 26. And then my 2 negatives will make a positive. So there. What? Did I miss the trick? Oh, 36. Sorry, 36. It's one of those days, kids. Sorry. It's one of those days. Okay, so I'm going to put 36 here. I'm going to try not to erase the whole thing out. 36. I was worried that was going to take the whole thing. And now we can finish our drawing. Because if this is 36, what's the square root of 36? 6, you're under y, so 6 up, 6 down. Oh man, this is going to be a big one. Now, I'm also going to put, so I know the height of it. I haven't put on the vertices on the side. I just have the foci. But we know it. You got 100, so I got to go, God, why did I make this one so big? 10 right and 10 left. This is going to be good. I can already sense it. And there. Hey, are your drawing skills that much better?
Yes.
Okay, all right. I didn't need that. Thank you, kids. Thank you. So that is as wild as ellipses get. You just have to be careful if your fraction is reduced. You have to kind of twist that and be careful of that. All right, nothing too